Welcome back to the course on blockchain architecture, design and use cases. So, in the last class we have seen about the basic proof of work mechanism in Hashcash, and today we will look into that how Bitcoin Hashcash extends that how the Bitcoin proof of work extends the Hashcash proof of work based systems and develop a methodology to protect the blockchain by applying a distributed consensus mechanism. And along with that, we will also look into several other consensus algorithms which are being applied on permissionless model of blockchain, which are most similar to Bitcoin based architecture, and how they utilize the concept of consensus to ensure a secure tamper proof blockchain. So, this Bitcoin proof of work, it is based on Hashcash proof of work system. So, the miners who are the special nodes in Bitcoin network who participate in the consensus procedure, they need to give a proof that they have done some work before proposing a new block. So, if they can successfully complete that work, then they are able to submit that block as a part of the existing longest chain of the blockchain. Now, the attacker they will be in general discouraged to propose a new block or make a change in the existing block, because they have to do the entire work of the blockchain, which is computationally difficult in a generic environment. So, this is the methodology for Bitcoin proof of work system. So, in case of Bitcoin proof of work system, you have an existing blockchain. So, if you remember the basic blockchain architecture, in the basic blockchain architecture, every block is connected to the previous block with the hash value. So, here this pH is the hash value of the previous block. We have this previous hash value and one nonce value which is included in every block. So, we need to encode or we need to include this one of these existing 3 proposed blocks with the existing blockchain. So, every miner they will try to find out a nonce value which will satisfy certain hash equation. So, this is the hash equation that they have to perform. So, you have the previous block hash, along with you have the Merkle root of the transaction. So, if you remember that all the transactions are arranged in the form of a Merkle tree, which is again a hash based architecture, and the root of the Merkle tree, it contains the root hash which we call as the Merkle root. So, it includes the Merkle root and along with a nonce value. Now, this block hash value, it has a given challenge. So, the challenge is that you have to ensure certain number of zeros at the prefix, just like we have did in the Hashcash based system. So, this is termed as the difficulty of the system. Now, the miners they will try with different values of nonce. So, they will try with different values of nonce to find out that for which hash value, or they have to find out a certain block hash value which has or which satisfies the difficulty, given difficulty, that is certain number of zeros at the prefix of the hash value. Now, every individual miner they will independently try to find out this nonce value, and the miner who will be able to first find out the nonce value for his own block, his or her own block, then he or she will be able to include that block as a part of the blockchain, as a part of the existing blockchain. So, this is the proof of work based system which is utilized in Bitcoin to ensure the consensus by utilizing challenge response based systems. Here the challenge is that by changing the nonce value, you have to find out hash with certain difficulty level, that means with certain number of zeros at the beginning, or better to say a maximum number of zeros at the prefix, a minimum number of zeros at the prefix, not maximum. That is the challenge which is imposed by the Bitcoin network, and every miner need to solve that problem to find out the corresponding hash function. So, most implementation of Bitcoin proof of work, it utilizes SHA 256 based hash function, which is a 256 bit hash function. The miners, they collect the transactions for approximately 10 minutes, which is a default setup. So, it waits for certain duration and looks for all the transactions which are coming within that duration. So, this is again a kind of approximate duration. So, this duration comes from the fact that at what periodicity the miner should mine a new block. So, those different steps we will look into later. So, ideally they wait for certain duration approximately 10 minutes and look for all the incoming transactions, and within that duration if they get an updated blockchain, then they find out that which transactions have already been included in the block, and by excluding those transactions which are already been included in the existing blockchain, they take the next the new set of transactions to propose a new block and starts the mining procedure. That means start finding out the corresponding hash value. Now, the probability of getting a proof of work is low. So, because the probability is low, it is difficult to say which miner will be able to generate the block. So, you have multiple miners who are simultaneously trying to generate a block, and one of the miners out of those hundreds or thousand miners who are there in the Bitcoin network, one of them will generate the block, and that way because this probability is low, no miners will be able to control the Bitcoin network single handedly. So, it will not happen, ideally it will not happen that no miners will be able to generate all the blocks in the Bitcoin network. So, that level of randomization is supported by the Bitcoin consensus protocol, which is the proof of work system. So, one point to note here that sometime in some literature this Bitcoin proof of work mechanism, it is also termed as Nakamoto consensus, based on the proposal came from Satoshi Nakamoto. So, some people also term it as Nakamoto consensus. Okay. So, let us see that why Bitcoin proof of work mechanism is tamper proof. So, this is the broad architecture of a block. So, in every block as we have learned till now that every individual node they have to find out the nonce, and this so that this current hash, the hash for this block, it satisfies certain difficulty, like the minimum number of zeros that should be there in the prefix. So, this hash value, the current hash value of one block, it is included as a part of the previous block. So, these things we have seen earlier. So, that way if some attacker want to make some changes in one block, then they have to actually do the collective work, or better to say they have to do more work compared to the collective work of all the blocks in the chain. So, every block in the chain, it has been obtained by doing some work by individual miners, where the miners have found out the nonce value based on the difficulty level. So, the attacker have to do a collective work which is more than the total collective work of all the blocks in the current blockchain. So, that way this is difficult with the current hardware. So, note the term that making an attack or tampering the current blockchain is difficult with the current hardware, but remember that it is not impossible. So, if the attacker can do the work with by investing a huge hardware which can compute the hash very fast, and it will be able to change all the hash values of all the blocks in the longest chain, then the attacker may be able to make a change in the blockchain or tamper the blockchain. But although it is computationally feasible, but there are two aspects. First of all, the time required to do that work, ideally it should be significantly high. If the miner invests huge amount of hardware to do that things, then the total amount of investment that the attacker is doing to launch this attack, that should be obviously less than the gain that he or she will get by performing this attack. So, that way ideally people think of that, although this is not deterministically tamper proof, it is always possible to tamper the blockchain with very fast hardware in the future, but ideally people believe that the attacker will be discouraged to launch an attack on the blockchain network, because they have to do more work compared to the collective work of all the blocks in the longest chain. Well, so this proof of work also solves a problem in any digital cryptocurrency, which we known as double spending problem, or this double spending can also work like an attack sometime. So, the double spending means the successful use of the same fund twice. So, the attacker is trying to transfer the same Bitcoin to two different person almost at the same instance of time. So, the attacker can launch a transaction say to B with certain Bitcoin, with certain say Bitcoin 20, and then the attacker launches another transaction to C with the same Bitcoin 20, and here the attacker say has only 20 Bitcoin with him or her. So, that way this kind of attack is known as the double spending attack in the digital currency literature. So, Bitcoin, by utilizing this proof of work mechanism, it also solves the double spending problem, because the transactions that we are putting in the block they are irreversible, or at least they are computationally impractical to modify. We are not saying that it is impossible to modify, but as I have mentioned that the attacker have to do a significant amount of work, or rather they have to do the work more than the collective work of the blockchain, and that way it is computationally impractical, and that is why the attacker will not be encouraged to launch this kind of attack. So, that way whatever transactions which have been already submitted in the blocks, they are kind of permanent transactions. So, they are kind of permanent transactions means you can think of them as the permanent ledger, and whenever some new transaction comes, you can always validate that whether the new transaction conforms with the existing transactions which are there in the blockchain. So, that way if this initial transaction has already committed in the blockchain, from where you can find out that the attacker has only 20 Bitcoin with him or her, and if the attacker is going to issue two different transactions of Bitcoin 20, which is not possible, like if the attacker is going to launch a kind of double spending attack. So, the miners or the nodes in the Bitcoin network can verify that, and they can actually block such kind of double spending to happen over the Bitcoin network. So, that way by making the entire system kind of tamper proof, the proof of work mechanism ensures that the double spending does not happen in case of a blockchain network. Well, there can be certain type of attacks which can happen on a proof of work based system, and one popular attack that people are trying to perform is the Seibel attack. So, in case of Seibel attack, the attacker attempts to fill the network with the clients under his control. So, if the attacker can fill the network with clients under his control, then the attacker can actually control or get a monopoly over the network, and these clients can do different kind of actions based on the instruction from the attacker. They can refuse to relay the valid blocks, they can only relay the blocks which are generated by the attackers. Those blocks can lead to double spending. So, that way in the Seibel attack, the attacker can include multiple such nodes in the network who can collectively compromise the proof of work mechanism. Now, to solve this problem, the Bitcoin network it apply a solution technique where it diversify the connections. So, the Bitcoin only allows the outbound connection to one IP per /16 IP address. So, if you have say IP address series of say something like 172.16 dot something /16, So, in this entire network you can have at most one peer. So, that way if you diversify the network, it is expected that if the attacker generates multiple such false miners, the attacker will generate them within the same network. So, they will be clustered within same subnet. So, that is the expectation, and with this expectation people find it that well the Seibel attack may be possible. But if you diversify the outgoing connection, that whenever you are forwarding the block, you forward the block to multiple nodes rather than a cluster of nodes in the same network. So, the entire idea is something like that. Say you are forwarding a block, and all these blocks, all these nodes belong to a single cluster. So, in that case you just make a connection to one of the node in this connection where you will forward the block, and then you can have multiple other peers where you can forward the block or forward the valid transaction. So, in that case it will not happen that you are connected, your peers are only from the attack nodes and they are not collectively relaying your transaction. So, that way blockchain expects or blockchain makes the Seibel attack hard to implement on a distributed network, but remember that although this solution makes it hard to launch a Seibel attack, but it does not make it impossible. It is always possible to launch multiple attackers at multiple subnets and then collectively control them and then launch the attack in a distributed way. But launching those kind of attack is much difficult in a real network. So, the next type of attack which can happen on a proof of work based system, it is the denial of service based attack. So, in denial of service based attack, the attacker send a lot of data to a particular node, and if you are sending a lot of data to a particular node, the node will not be able to process the normal Bitcoin transactions. So, that is a typical denial of service attack which can be happen on a proof of work based system, and to solve this kind of denial of service attack, Bitcoin has a set of rules like you do not forward orphan block. Orphan block means the block which have been forked from the main chain. So, if a block does not belong to the main chain which is the longest blockchain, you do not forward those blocks. Then do not forward the double spend transactions. If you have found out that a transaction has already been forwarded, so you do not forward the transactions further. Then do not forward the same block or transactions twice. Then disconnect a peer that sends too many messages. If a peer sends you too many of messages, too many of transactions, then you disconnect that particular peer. Then you restrict the block size to 1 MB. So, restricting the block size has an implication on solving the denial of service problem. If you have a larger block, in a larger block you can put more transactions, and the larger block becomes difficult to verify by the common normal nodes. So, the normal Bitcoin nodes which are there, if they are getting a large block, it may be difficult for them to verify the large block. So, that way if you are restricting the size of the block, it becomes easier to forward the block to many peers in the network. So, that is why the standard Bitcoin network as proposed by Satoshi Nakamoto, it blocks or it restricts the block size to something like 1 MB, and nowadays with the current Bitcoin version it can go up to 8 MB. Then limit the size of the Bitcoin script. So, we have discussed earlier the concept of Bitcoin scripting language, where you provide the instruction that how to validate or how to match the input of a transaction to the output of the next transaction, or how to match the output of a transaction to the input of the next transaction. So, this Bitcoin script, there is certain limitation on the Bitcoin script that you limit the size of each Bitcoin script to something like 10,000 bytes. So, do not have a Bitcoin script more than that. If you have a larger Bitcoin script, that is more susceptible to attack. So, do not forward transaction which has this kind of larger scripts. So, by taking, there are certain other measures, there is a huge list of measures that Bitcoin network takes to solve denial of service attack over the proof of work based systems. Well, now let us look that whether it is possible to break the Bitcoin proof of work or not. So, as we have mentioned earlier that Bitcoin proof of work is computationally difficult to break, that is the important term. It is computationally difficult to break, but it is not impossible to break the proof of work based system. So, the attackers can always deploy high power servers, or by deploying those high power servers they can do more work than the total work of the blockchain, and that way they can tamper the entire blockchain network. So, there is one example, one known case of successful double spending which came from a mining pool called ghash.io. So, this concept of mining pool we will discuss later on. The mining pool means a set of miners coming together collectively and they are trying to mine a new block. So, that we call as a mining pool. So, this ghash.io mining pool, it was discovered in November 2013 that ghash.io mining pool, they appear to be engaging in repeated payment fraud against Bitcoin DICE, which is a gambling website. So, that kind of double spending that has happened over there. So, ghash.io they were able to launch a double spending attack over the Bitcoin network. So, that is one problem, and that problem particularly comes because of something called the monopoly problem in the proof of work based system. So, this proof of work, if you look into the proof of work based system, proof of work depends on the computing resource available to a miner. So, if a miner can pause a huge amount of computational resource, then the miner has then there is a possibility that the miner can control the entire network, because he has some huge hardware, some huge server like GPU server or something like that, where he can parallelly do the computation of the hashing, and by doing parallel computation of the hashing, and later on we will see that there are specialized hardware available for doing the Bitcoin mining. By applying those kind of parallel hashing, or by deploying huge servers for Bitcoin mining, and an attacker or a miner can gain control over the network. So, it may happen that a miner can gradually do or generate lots of blocks in the current blockchain. Now, if a huge number of blocks in the blockchain goes to a single miner, then this miner has the ability to control the entire flow of transactions in the blockchain. So, this particular problem we call as the monopoly problem in Bitcoin network, where the miners have more resources, have more probability to complete the work. And there is a statistical theory called tragedy of the commons. So, the tragedy of the commons theory which says, which is from the economic perspective, it says that such kind of monopoly can increase over time. So, why such kind of monopoly can increase over time? So, if you remember the rewarding system, whenever the miner mines a new block, they get certain reward. But to limit the total amount of Bitcoin influx in the economic system, we make a restriction about what is the total number of Bitcoin that can be generated out of the mining procedure. So, whenever we limit the total number of Bitcoin that can be generated out of the mining procedure, with time the amount of reward that will be given to the miners, that will drop, because the amount of Bitcoin that can be generated, that is also gradually dropping to make it saturated. So, because of that, whenever the miners will get less reward over time, so the users will get discouraged to participate or to join as a miner. Now, if the user get discouraged to join as a miner, then few miners with large computing resources, they may get control over the entire network. So, that is a practical problem which is not there in today's Bitcoin network, but with time it is expected that this kind of problem may arise, where because of the shortage of reward which is coming from the mining procedure, only the miners who are having huge computation power, they are only participating in the mining procedure. And indeed, nowadays we are in a time when we have already started seeing this kind of phenomenon. Nowadays, you cannot participate in a mining procedure just with a general purpose CPU. If you just install the Bitcoin mining software in a general purpose CPU, hardly you will see that you are able to generate a new block. So, in that way, only the miners with huge amount of computing resources, over the time they will get control over the Bitcoin network. So, this particular problem we call as the monopoly problem, which is a shortcoming of the proof of work based system. Another problem of this proof of work based system is the power consumption. So, this proof of work based system, it relies on the amount of power which is being consumed, because whenever you are deploying huge amount of computational resources in the network, it is expected that those computational resources are actually consuming a huge amount of power to generate those hash functions. So, that way this curve typically shows the amount of power consumptions with the Bitcoin network. So, you can see that with time there is a kind of exponential growth in the power consumption due to Bitcoin mining. So, to reduce these two problem, to handle monopoly and the power consumption in a proof of work based system, different other consensus mechanism came into practice. One popular is this proof of stake mechanism. So, this proof of stake mechanism, it is possibly proposed in 2011 by a member in the Bitcoin forum. So, the idea was that you make a general transition from a proof of work based system to a proof of stake based system when the Bitcoins are getting widely distributed. Now, the broad difference between a proof of work based system and a proof of stake based system is as follows. In case of proof of work, the probability of mining a block depends on the work done by the miner. So, the amount of work, if the miner has huge resources, huge computing resources, if the miner can do a huge amount of work, the probability of getting a new block gets increased. On the other hand, in case of proof of stake, the amount of Bitcoin that the miner holds, that instructs that which miner can generate the next block. So, if a miner holds 1% of the total Bitcoin, the miner can mine 1% of the proof of stake block. So, by putting this kind of restriction that on the amount of Bitcoin that the miner holds, and proportional to that the miner will be able to generate the proof of stake block, you can basically reduce, or you can reduce certain or this kind of monopoly problem, or you can make the monopoly problem to appear as a difficult problem for a proof of stake based system, because the inherent assumption is that by the proof of work based system the Bitcoin is widely distributed. So, every miner will be able to participate in the mining procedure proportional to the amount of Bitcoin that he or she possesses. So, this proof of stake based system or PoS based system, it provides increased protection. So, executing an attack is expensive, you require more Bitcoin if you want to generate more block, and you also have a reduced incentive for attack, because to generate an attack you need to have a huge amount of Bitcoin in your hold. Now, if you already have a huge amount of Bitcoin in your hold, and if you are generating an attack on the blockchain network, that means you will be mostly affected, because you are holding a majority of the Bitcoins with you. So, that way the attacks are more expensive in a proof of stake based system. Now, there are multiple variants of stake, or stake is basically the term wealthness that you have. There are multiple variants of stake that has been discussed in the literature. One idea was to make a randomization in combination of the stake, which is used in this Next and Black coin cryptocurrencies. So, the idea is that you consider the amount of Bitcoin that you have as an input, and at the same time you apply a randomization function, and based on that randomization function you decide that who will be the miner who will generate the next block. Then there is another one which has been used in another cryptocurrency called peer coin, the concept of coinage. So, the coinage is that number of coins multiplied by the number of days the coin have been held. So, to participate in a peer coin system, it is apart from holding a huge amount of Bitcoin with you, not huge amount of Bitcoin, sufficient amount of Bitcoin with you, you have to also ensure that you are holding those Bitcoin for certain duration. So, this way if some attacker just collect a huge amount of Bitcoin by launching some attack or participating in some transactions, immediately he or she will not be able to participate in the mining procedure. So, that way this coinage also prevents the case when the attacker can do certain transactions immediately to gain more amount of bitcoins, and by gaining more amount of bitcoins get more probability to mine a new block. So, these are the two variants of proof of work based system. So, another consensus mechanism that has been discussed widely in the literature, it is called proof of burn. In case of proof of burn, the miner should show a proof that they have burned some coins. So, by burning, it is like that they have to send them to a verifiably unspendable address, and during the discussion of Bitcoin script, we have shown you that how you can write a script through which you can send some Bitcoin to a verifiable unspendable address where no one will be able to spend that Bitcoin. So, you have to burn that coin. So, the idea here is that it is as expensive as proof of work. In case of proof of work, your investment was the physical resources like your computational power and the computation time and the electricity bill that you have to provide for that, and physical money that you have to invest to purchase computational hardwares. Here you have to spend digital or logical resources which are the bitcoins. So, you have to spend certain bitcoins to participate in the mining procedure to show that you have interest in generating the mining. So, if the attacker wants to attack this system, the attacker actually have to make a loss of huge amount of bitcoins, and at the same time this particular system is power efficient because you are not utilizing physical hardware to do the work, rather you are spending these digital currencies for that, and that is why although it is expensive like proof of work, but it is efficient in terms of the power consumption, because nowadays now you are not utilizing this power hungry hardware to perform the hash functions. So, the difference between proof of work and proof of burn is that in case of proof of work you are utilizing real resources, whereas in case of proof of burn you are utilizing virtualized or the digital resources. But remember that all this proof of burn or proof of stake mechanism they came after proof of work. That means, once the proof of work gets settled down and people have certain amount of digital currencies with them, then gradually you can move to proof of stake or proof of burn based mechanism. So, this proof of burn works by burning some proof of work mined cryptocurrencies. So, the original cryptocurrencies was mined by proof of work, then you are burning them to participate in the next mining procedure when the proof of work system got saturated. So, this is the broad difference between the three: proof of work, proof of stake and proof of burn. In case of proof of work, you do some work to mine a new block. So, you find out hash function for that, which is computationally difficult. In case of proof of stake, you acquire sufficient stake or wealth to mine a new block. You have to show that you have certain amount of bitcoins with you, so that you can participate in the mining procedure. In case of proof of burn, you have to burn some wealth to mine a new block. So, so you have to, just like proof of work, you have to expense certain bitcoins rather than the physical currencies to participate in the mining procedure. So, in case of proof of work, it consumes physical resources like CPU power and time. Proof of stake, as such, it consumes no external resource, but you can participate in the transactions. In case of proof of burn, you consume virtual or digital resources like the coins. Now, the proof of work, it is a power hungry mechanism. Proof of stake, it is power efficient. Proof of burn, it is also power efficient, because you are burning the digital currency and not the physical currency. There was another consensus algorithm which was proposed by Intel as a part of the Intel blockchain environment, which is called Hyperledger Sawtooth. That algorithm is called the proof of elapsed time. So, the idea of this proof of elapsed time is very simple, like each participant in the blockchain network waits a random amount of time. The first participant to finish become the leader for the new block. So, you actually make a randomization among the miners. So, the miner who will be able to complete that random waiting first, that miner will be able to propose the new block. But here the challenge is that how will you verify that the proposer has really waited for a random amount of time. So, if it is a software control, then an attacker can make a change in the software code and may claim that, well, I have waited for 1/22 before participating in the mining procedure. Now, to verify that, Intel utilizes a special CPU instruction set which is called the Intel Software Guard Extension or SGX, which is based on a trusted execution platform. So, this trusted execution platform is a hardware code, a hardware platform where you can write trusted code in a private way and that code is private to the rest of the application. So, it is completely hardware control, it is not software control. So, the specialized hardware, it provides an attestation that the trusted code has been set up correctly and the trusted code, say if you have implemented this randomization waiting time as a part of the trusted code, that have been implemented correctly and that have been executed correctly. So, you are giving a guarantee from the hardware itself, not at the software level. So, the attacker will not be able to modify that. So, here are some interesting reads regarding this different kind of consensus algorithms, blockchain consensus algorithm. The first one it gives analysis on this double spending mechanism on Bitcoin. So, it is a nice statistical analysis of the double spending. Then the second link is on the proposal of proof of stake. So, you can look into different interesting ideas there. The third one is the peer coin protocol that has utilized the proof of burn mechanism, and the fourth one is the Hyperledger Sawtooth platform. So, you can explore the internal details of the architecture of this Sawtooth platform. So, these are all about the basic consensus protocol in a Bitcoin type cryptocurrency environment that utilize permissionless blockchain environment. So, this proof of elapsed time, remember that this proof of elapsed time, that particular algorithm it was implemented by Intel under a permission model. Later on we will discuss the permission model in details, but initially people have proposed that for the permissionless model as well. So, the only difficulty there is that you have to post that special Intel SGX hardware which implements a trusted execution environment. So, the last algorithm proof of elapsed time, that is both for the permissionless as well as for the permission environment, but for the other consensus algorithm that we have discussed, proof of work, proof of stake and proof of burn, they are primarily for a permissionless environment. So, that is a brief idea about different kind of consensus algorithm, and in the next class we will talk about the basic mining properties and the task of a miner in Bitcoin. So, see you in the next class. Thank you.